What affects Wi-Fi speed? In a business or enterprise, there may be various factors regarding what affects Wi-Fi speed. Furthermore, performance, coverage, or connection speed. Some are easy to fix, others require troubleshooting or a high technical level of investigation. Wi-Fi is now the way of the world, and it is a necessity in the majority of buildings. When you rely on Wi-Fi, performance issues can cause problems with your efficiency. Unfortunately, Wi-Fi performance issues are not always easy to diagnose due to the way Wi-Fi works. An unknown changeable could potentially affect your Wi-Fi speed. Many factors distress the value of your Wi-Fi connection. Seemingly trivial things, such as turning the router or placing it higher, can make the difference between a good video Wi-Fi connection and a broken sequence of cut-in dialogues. Here are just a few key factors of what affects Wi-Fi speed. Antennas, impact coverage and Wi-Fi transmissions. The antenna in your service equipment may affect Wi-Fi coverage. Antennas have a significant effect on the Wi-Fi coverage your business or company receives. When looking at Wi-Fi performance, make sure the antenna is deployed, or built into your Wi-Fi access points correctly. This is especially true with access points with additional external antennas. Antennas are usually located inside a building or office. However, they can also be set up from the outside. If your antenna is close to any structure, such as a metal grid or cement beam, it can affect Wi-Fi transmission. Equipment power levels affect Wi-Fi performance. The power level of your Wi-Fi equipment affects speed. It's not always good when it comes to Wi-Fi power levels. The power levels transmitted through your access points are important, and do not need to be sufficient for coverage. Power is not always specified on the datasheet, or settings that come with your Wi-Fi equipment. Wi-Fi coverage problems can be caused by low levels of electricity. Improvements can be made with the Wi-Fi equipment's automatic power control algorithm. Therefore, detecting any neighboring access points. Therefore, lower levels of transmission which then corrupts neighboring access points results in increased performance. Equipment quality and build. Industrial and government standards have strict requirements on the radio parameters of networking devices, but do not meet specific performance requirements. As a result, the quality and performance of Wi-Fi networks also depend on the many design choices that manufacturers make. Some of these are deliberate choices, as manufacturers seek to cover the full scope of the price-performance spectrum. Others are specific to how the units are designed and built and what the manufacturer can do. The RF chain. An RF chain is the part of a smartphone, tablet, laptop, Wi-Fi access point, etc., which encodes, transmits, receives, and decodes radio signals. This quality is important for the quality and strength of the wireless signals, and the quality of the network connection they are carrying. Sometimes, RF chain standards are not very consistent. For example, a high-quality smartphone's network performance will be negatively affected by a poor-quality Wi-Fi app. Environmental factors. Hardware aside, practical knowledge shows that deploying the same tools in different environments results in different performance characteristics. Some environmental factors, such as when you install a wireless access point, are firmly under your control. Others, such as RF noise and interference, are not entirely up to you, so you need to keep these in mind when designing a Wi-Fi network. Different environments will create different challenges. Furthermore, those challenges will affect the performance of your Wi-Fi system. RF noise and interference. All Wi-Fi devices operate in multiple frequency bands in the 2.4 GHz and 5 GHz spectrum. The all part is very broad. It includes your Wi-Fi devices, your neighbor's Wi-Fi devices. They all work in this spectrum, and sometimes they can interfere with each other. This hurts the quality of Wi-Fi signals. Not all intervention is suitable for Wi-Fi strategy. Other wireless protocols, such as Bluetooth and Zigbee, run in the same frequency band as Wi-Fi. And sometimes interference is completely accidental. USB 3.0 cables with a bad screen, for example, can produce significant RF noise. Unusual cases such as a staff canteen microwave have also been known to affect data networks. The presence of RF interference reduces the performance of the Wi-Fi network, and its effects are due to the proximity of the Wi-Fi access point. As a result, wireless access points are placed so that they are close enough to any client's equipment, even if they do not interfere with each other yet. Wi-Fi units positioning. Most people do not underestimate the importance of choosing a good location for a Wi-Fi access point. Even a small change in positioning can make a huge difference in performance. High versus low. Placing your Wi-Fi router on the floor or behind other things usually leads to poor performance. Instead, keep the router as high as possible to increase the transmission range of the radio waves. It also helps to clear the router of possible interference. The unit must also be orientated in the correct way to maximize the antennas of the unit. This is regardless of them being internal or external antennas. Objects in the way such as concrete, plaster, and especially metal results in a negative effect that blocks Wi-Fi waves. Therefore, with wireless access points, the closer you block yourself to an obstruction like a brick wall, the more you block its signal. The further you are from your router, the weaker the Wi-Fi signal. Therefore, the best option is to keep your access points as close to your devices as possible. An in-depth Wi-Fi survey and design will calculate the optimum number of units to cover your devices without overpopulating. Device installation. Being placed in the right place is not the only factor that affects performance. Many other factors related to the position of the access point have important consequences. For example, an antenna does not circulate RF signals evenly. Just above the antenna, there is a narrow region, where the signal strength is very low. An antenna's familiarity with client equipment and the surrounding environment, walls, structural elements, can affect the quality of the Wi-Fi signal. Uplink speed and load. Locations with Wi-Fi access still need to connect to the rest of your network and then to the internet. For example, traffic between different departments will pass through more devices than just one Wi-Fi access point. And, of course, internet traffic passes through your ISP. The performance of your Wi-Fi connection depends on how fast and busy the network is on the other side of the wireless access point. It's not something you can underestimate in the wireless aspect, but it's something you have to keep in mind. Wi-Fi traffic is very diverse. For example, smartphones can download hundreds of megabytes of firmware upgrades without even knowing. Therefore, when multiplied by a whole office, this adds up very quickly. Therefore, when considering what affects Wi-Fi speed, you need to consider all the elements involved. For further assistance or a free survey, please email or call on the details below, and click like and subscribe if you have enjoyed this video.